We need to stop relying on planes for our mode of transportation.
I believe Hyperloop is the future. In just 30 years, we will have built it, and it will be the most efficient mode of transportation yet.
I want to contribute to a sustainable future, not just for me, but for all the future generations.
Hyperloop will change the way we travel. A fast and comfortable journey without any concessions.
What defines us is our adaptability during setbacks. We are designing on the edge of what is possible.
We are Delft Hyperloop 6.
I joined Delft Hyperloop to work with a team of the most ambitious and high-performance students out there.
A challenge. That is what the realization of Hyperloop means to me. It also means a solution to climate change, to long travel hours, and to the slow distribution of goods.
We create, we innovate, we take the lead.
Good evening and welcome to all of our friends, family, partners, alumni and team members. It's my privilege to welcome you all here this evening. We're so excited to share with all of you what we have been working so hard on for the last 6 months. My name is Patrick Shepherd, and I am the team captain of Delft Hyperloop 6. It is my responsibility to ensure that our top-level strategy is one that allows us to reach our goals. It is also my responsibility to manage the human resources side of the team and ensure that all of our individually amazing team members work together as one coherent group and stay driven and motivated towards the same goals. Now, before we dive into what we have done this year, I'd like to take you all back with me on a journey. It was around 8 months ago. I had just finished my final presentation for my bachelor's. I turned on the news, expecting to see the latest update about the coronavirus pandemic. But instead, I was shocked. I saw a natural disaster, floods. And no, not in some faraway country on the other side of the world, but right here in Western Europe. And I was taken aback. For me, this made me realize climate change is urgent, and it is happening. And the thoughts that it won't affect me is not a thought that can be there any longer. So, the Hyperloop, floods. You're probably thinking, where is the connection? Well, for that, we need to look at CO2 emissions, the biggest contributor to climate change. So let's zoom in on the transport sector. We see that the transport sector contributes to 31% of the total greenhouse emissions. And if we look at this over time, this proportion is only increasing and increasing. So let's dive into this transport sector a bit further. We currently have 4 modes of transportation. You're probably familiar with most of them. And if we look, the last revolution in transportation was over 100 years ago, the plane. Now, I'd like to pose a question to all of you. Have you ever been planning a holiday, say, to the south of France, and you were considering a plane? that is very fast, comfortable, but also polluting. And on the other hand, you are considering a train, a lot more environmentally friendly, but a lot slower. Well, I've been in this situation myself. And much like many of you, I assume, I chose the plane. And my question is, can you blame us? But that is why we at Delft Hyperloop believe in a solution, in a fifth mode of transportation, one where you don't have to choose between speed and comfort and the environment. And that is why we think it's time to be part of the solution. And it's time for innovation. And that is why it is time for the Hyperloop. So I've explained why we need the Hyperloop, what the current challenges of climate change are, but how does it work? Well, this can be explained in a few simple building blocks. First of all, what do we travel in? We call this a pod. It can be seen as something similar to a train carriage. The second thing we do, and the second variable we need to look at, is something that we've become all too familiar with over the last few days with the storms in the Netherlands. And that is air resistance. This is the first variable we remove. We do this by traveling through a near vacuum environment. Secondly, rolling resistance. This is the second variable we remove. We do this by means of a magnetic levitation system. And lastly, we need to move our pod forward. And this is done with a magnetic propulsion system. So, how does the Hyperloop compare to all of the other modes of transportation we have? Well, here we can see that the airplane is by far the fastest form of transportation that exists, and the train the most environmentally friendly. Let's add the Hyperloop. We can instantly see that the Hyperloop travels at 1,000 kilometers per hour, faster than a plane, and at 1/3 of the energy of a train. Now, ladies and gentlemen, when I saw this chart a few years ago, it became instantly clear to me. The Hyperloop is the future. So, you're probably all thinking, how does a group of 38 students from the TU Delft contribute to this? For that, I need to take you to our mission. Our mission has 3 major focuses: the desire, the technology, and the infrastructure for the future implementation of the Hyperloop system. The desire. The Hyperloop is a very new form of transportation. We need to explain how it works to people, show them that it really is safe, and the passenger experience is an enjoyable one. We at Delft Hyperloop also believe in an all-encompassing solution, one where we develop the best technology and do research into the future infrastructure required, so that we can have a seamless transition in the future. But how do we contribute to this mission statement in just 1 year? Well, we do that by means of competing in the European Hyperloop Week, a competition where 34 selected teams from all over the world, ranging from North America to Singapore, come together and compete to push each other to do the best research and develop the best technology. And this year, for the first time ever, the European Hyperloop Week comes to the Netherlands. We're extremely excited to host all of these teams from around the world and compete for the title on our home turf. So we have the need, what the Hyperloop is, and a means of contributing. So it's time for the goal of Delft Hyperloop 6. Our goal is to strive to win all awards at the European Hyperloop Week in July of 2022. An ambitious goal, a challenging one we truly believe we can accomplish, but we need a great team. And I would like to take you on the journey of this team. 6 months ago, we came together in August as a group of 38 individuals, not yet a team. We started brainstorming. We started exploring our reasons why and our motivations, and tried combining these into a collective one in order to try and craft a culture that will allow us to be the elite team we need to be. And what we have today is a culture of collaboration, one where we use our differences in character and our diverse backgrounds to pull the best out of each other and to make each other better every single day. And that is the journey we're on. One where we're constantly trying to reflect to see how we can do better, what's going well, and how we can be the best team at the end of the year. And this team is the team that we as management are so proud to present to you all today. Delft Hyperloop 6. With this team, we are going to take 3 giant leaps forward. We are going to develop the best pod Delft Hyperloop has ever seen. And ladies and gentlemen, with this team, we are ready to take the lead. I'd now like to hand over to Thijs Bolscher, our project manager, to tell you a little bit more about how we do this.
Good evening, ladies and gentlemen. It is so good to see you all here and to have all of you watching at home tonight. We are beyond excited to show you what this team has been working so hard on. My name is Thijs Bolscher, and I am the project manager of this great team. It is my responsibility that this team is provided with the right resources at the right time. I make sure that all the time and money that we have at hand are distributed as efficiently as possible. And now, before I can actually show you why this team and what they're doing this year are so special, I need to show you Delft Hyperloop's past. Now, ladies and gentlemen, I think you might understand that this is the history that we are so proud of today. This is the history that we build upon. And it all started with DHO1 back in 2016. Back then, inspired by Elon Musk's visionary idea, DHO1 took part in the first edition of the SpaceX Hyperloop competition that took place in Los Angeles. In this first edition, Delft Hyperloop took home the first prize, beating over 2,000 competing teams along the way. DHO2 took part in the third edition of the SpaceX competition. However, due to an overheating temperature sensor, the pod came to a standstill after reaching 142 kilometers an hour. DHO3 was the last Delft Hyperloop team to take part in the SpaceX competition. DHO3 was a multidisciplinary team with students from Amsterdam and Delft. They reached speeds of over 200 kilometers an hour. This gave them the fourth place in the competition. Once again, Delft Hyperloop beat hundreds of teams from over the whole world. Then DHO4. This team had to deal with the uncertainties of COVID. Throughout the year, the team wasn't even certain if the competition would actually take place. In the end, this team overcame these uncertainties as they came together and reached a record top speed of 360 kilometers an hour. Then our direct predecessors, DHO5. DHO5 was the first Delft Hyperloop team to take part in a new competition, the European Hyperloop Week. This competition focused way more on scalability and the realization of the Hyperloop system, instead of just speed, as the SpaceX competition did. For this, Delft Hyperloop 5 took a very brave step. They chose for a new, revolutionary, and highly efficient type of propulsion system, the linear synchronous motor. In the end, Delft Hyperloop 5 took home 3 awards at the European Hyperloop Week, one of which was the Jury's Choice Award, for which the jury looks at which team made the biggest leap towards a scalable Hyperloop system. These teams are our inspiration. These teams are our foundation. And as I said, these teams are what we build upon today. Now this year, it was our turn. And we decided it was time to take matters into our own hands. We decided it was time we take the lead. Delft Hyperloop 6 stretches what can be done with 38 students in only 1 year. Students who learned how to design but have no hands-on experience producing or testing a technical prototype. So no experience? What does this mean? It means that we need to learn quickly. Things will happen that you cannot foresee. Let me take you back to October. Back then, we spoke to one of our partners who would deliver to us the motor drives, basically the heart and the lungs of our propulsion system. That day, we learned that the delivery times of those motor drives were way longer than we expected. We put our heads together and we started looking everywhere for those motor drives that our system needed. In the end, in a small museum in Berlin, we found a test setup, a huge test setup, with exactly those motor drives that our system needed. We started looking for 4 motor drives, and we ended up with a 9,000 kilogram test setup. The floor of our workspace couldn't even carry it. Now, I dare to say, ladies and gentlemen, that setbacks like these, we are used to them. The solution-oriented mindset of this team keeps surprising me. And trust me, it will surprise you. Now let me show you what a typical year at Delft Hyperloop looks like until we get to the competition in July. We start with the design phase. During the first 4 months of the project, our engineers need to come up with a concept and need to work it out to its finest detail. For this, our engineers need astronomical effort and a tremendous eye for detail. Once everything is designed, we go on to our production phase. This is the phase that we are in today. Our engineers finally get to put their hands to work to produce what they designed weeks earlier. Drawings become materials, and materials become parts. And once everything has been produced, we start putting things together. For the first time, we really start recognizing the subsystems that we designed weeks earlier. Our pod really comes to life during what we call the assembly phase. And now our system has been put together, we start testing. The goal of the test phase is to make sure that our system is so robust that it can face all challenges and the competition at the European Hyperloop Week. Now, to make our dreams come true throughout the year and to rake all those resources together that we need, we have our business department. And this is the department that you know best. They are responsible for managing our partnership relations and our face to the outside world. Now, ladies and gentlemen, we are coming closer and closer to that moment that you have all been waiting for. I told you about our challenges this year, I told you about our history, and I told you about what a year at Delft Hyperloop looks like. I told you that this year, we take the lead. But how? This year, Delft Hyperloop 6 takes 3 giant leaps to solve 3 giant problems. The first of those problems is explained here. Imagine, in 15 years from now, the Hyperloop infrastructure could take you from Amsterdam to Brussels and from Brussels to Paris. If the Hyperloop system would not be able to switch lanes like a conventional train can, we would have to go from city to city, one after the other. And we would need to stop at every station, prolonging our travel hours. Now, if the Hyperloop system would actually be able to switch lanes, we would be able to use the same Hyperloop infrastructure that takes us from Amsterdam to Paris to also take us from Amsterdam to Brussels. And this would save us many kilometers of Hyperloop infrastructure, thus materials and thus cost. But before we can actually switch lanes with a Hyperloop system, we need to do something differently from a conventional train. Where a conventional train basically sits on its rails, this year, the Hyperloop system would need to hang below it. And this is exactly what we are building this year, a hanging system. Oh, and small detail, we are the first student team ever to do so. Let's move on to our second problem, rolling resistance. As Patrick explained to us at the start of this presentation, the Hyperloop system and concept relies on the fact that we take away almost all resistance. But before we can actually take away the rolling resistance, we need to do something new. We need to levitate. And this year, ladies and gentlemen, this is exactly what Delft Hyperloop 6 is doing. We will levitate. And then finally, on to our third giant problem. Because before the Hyperloop system can actually be implemented in the real world, we need a highly efficient propulsion system. I told you that last year, DHO5 took a brave step already. They chose for a new type, a new configuration for their propulsion system. However, within this configuration, there were still many steps to be taken until it becomes a scalable option. And this year, Delft Hyperloop 6 is taking those steps. We are building and we are coming closer to finding that propulsion system that you will find in the future Hyperloop. So 3 giant leaps. A hanging system, we are levitating, and we are building that propulsion system that you might find in the future Hyperloop system. And now we know all this. We are ready for that moment that you are all here for. I am beyond excited to show to you that design that this team has been working so hard on. I am beyond excited to reveal to you Helios 1.
Wow. I have seen this design go from a piece of scratch paper to a full 3D model to production. I see it every day and it still amazes me. I am Hidde de Bos and I'm the chief engineer of Delft Hyperloop 6, which means I'm the one responsible for making sure that all subsystems work together optimally. Tonight, I would like to take you on a journey through our new and improved design while showcasing the most radical decisions and changes we have made. As we've mentioned numerous times before, scalability is an imperative part in our design process. This is why we have a separate department for it. They research the technical side of a full-scale Hyperloop, as well as designing for a proper passenger experience. With scalability, we are getting ahead of the issues and laying down the framework for the future of transportation. All of this research trickles down into our engineering, because we are again focusing on a winning, scalable design. This is mostly embodied in our 3 design pillars. There's overlap between the 3 of them, but together they form the cornerstones of our new design. First is efficiency. Without efficiency, a Hyperloop can never overtake a conventional mode of transportation. Making the most use of the energy we have is the only way to building a usable system. Second is scalability. We need to bring our design into the real world. Scalability is what allows us, as Delft Hyperloop, to create technology for the future of transportation. Last but not least is robustness. We are aiming to win all awards at the EHW. We can only do so if our system has a reliable performance, meaning we can replicate test results over and over and over again. These 3 design pillars are part of every decision we've made within the past half year. We made sure that every part was carefully weighted to get the most out of all of them. You will see that every subsystem contributes elements, such that when they are combined, we have a system that fulfills them all optimally. Now, as Thijs already said, we are taking 3 giant leaps. I would like to now give you a bird's eye overview of how these 3 giant leaps are aligned with our 3 design pillars. For efficiency, we are building a hanging system with an efficient propulsion and levitation system. For scalability, the hanging system allows us to open doors in the future for the integration of propulsion and levitation, as well as giving us the opportunity to possibly high-speed lane switch. For robustness, the hanging system is more stable and we can exert more control than if we were sitting. With these design pillars, we are taking the lead. Now that you know how our 3 design pillars are aligned with our 3 giant challenges, I would like to walk you through our new design. Building a levitating system was one of our most crucial choices, so let us start there. This part of the system is designed, produced, assembled, and tested by our levitation department. They focused on finding the best possible levitation system by looking at our design pillars. By combining the efficiency, scalability, and robustness arguments, and considering all different options of levitation, they eventually settled on hybrid electromagnetic suspension, or HEMS. This HEMS is implemented via the 4 U-cores, of which you see a front view here. I will now explain to you how the system works. We start off with a steel track beam and an iron-shaped U-core. Both of these parts conduct magnetic fields really well. We then glue permanent magnets on top of our U-cores, and you will see that the magnetic field starts flowing. We are now pulled towards the track. Unfortunately, we are also stuck to the track as well. To make us come loose, we will use coils, which when powered, create a magnetic field in the opposite direction. By putting these coils around the U-cores, we can generate a magnetic field that opposes the field of the permanent magnets so far that we start coming off the track. We are now levitating. This system is more efficient than simply having coils attract to the track, since we only need to overcome the difference between the gravitational force downwards and the extra magnetic force upwards. Additionally, it adds an inherent safety feature. If the power is turned off, our pod will automatically go towards the track instead of dropping down. Lastly, with these coils, we can exert more control than if we were sitting, tuning the magnets exactly how we want them. Designing a system like this is extremely difficult. There are over 1,000 number of configurations varying the size of the core, the thickness of the magnets, and the amount of windings of the coils. Furthermore, the operational range of our U-cores is just 4 millimeters. A tiny amount. However, the magnets we need to attract ourselves to the track are so strong that when stationary, they can carry 4 full-sized camels. The difference between these 2 scales is enormous. On the one hand, we have super strong permanent magnets, and on the other, a tiny margin for error. The greatest challenge is keeping us off the track. Why? Imagine driving on the highway over a speed bump as large as me. That is the bump that is introduced by the 2 millimeter offsets in our track. A tiny amount, yet it still yields great problems. To keep us off the track, we need an incredibly fast control system, which is implemented via our 4 motor drivers. Now, because we wanted our pod to function in vacuum, these motor drives had to function with almost no air around. Unfortunately for us, our motor drives were not vacuum compatible, which meant that we had to design vacuum boxes. This turned out to be an unexpectedly great challenge. Apparently, making something vacuum compatible is quite hard. Who would have thought? These vacuum boxes make sure that our motor drives can play a pivotal role in keeping us off the track. Speaking of the track, it stands tall at 1.6 meters high and 1.4 meters wide, and weighs in at about 2.5 large African elephants, or about 14,000 kilograms in standard units. Its height and width may not be large. Its length rivals the length of a Boeing 777, coming in at 74.5 meters. We have to align this 74.5 meters with a margin of just 2 millimeters. Imagine looking over the top of a Boeing and spotting an offset of just 2 millimeters. It's incredibly hard. This is why we have designed the track to be highly adjustable. It consists of these beams on the top, underneath which our pod hangs. On the side, we have the beams to constrain the lateral movement of the pod. These beams are made such that they can catch the pod if it ever drops down. They are designed to be so strong that they can carry 2 Tesla Model X's on either side. In other words, this mechanism is insanely strong. Lastly, the track also provides the anchoring point for our propulsion system. Because this was another one of our great design choices. Because now that we are levitated and guided along a track, we need to move. This movement is created by the motor designed by our propulsion department. They have improved on last year's design by building a one-sided linear synchronous motor. A design that uses permanent magnets on the pod, oriented such that all the magnetic field is on one side, and with the coils in our track, we can then push our pod. By running current through these coils, we create a magnetic field which opposes the permanent magnets on the pod and propels our pod forwards. These coils feature a new and improved design allowing for larger full-scale speeds. Additionally, we have implemented a cooling system allowing us to easily reach efficiencies of over 80%. This cooling system is required because at a peak, we are pushing a peak voltage and peak current through the coils of about 400 volts at 134 amps, with the average used power being about 80 kilowatts. Not only is the system more efficient in terms of operation, it also allows for regenerative braking, a form of braking in which the coils slow down our pod, generating power that we can put back into the grid. Hence, the eventual speed generated by an already efficient system is almost entirely used to generate power instead of heat. Now that we are levitated and moving, we need a backbone to attach to. This is where our mechanical department comes in. Aside from designing and building the track, they are also responsible for the chassis. They have worked tirelessly to create a chassis that emulates real-life, full-scale Hyperloop designs. To do this, we decided to not be bound by any single material like previous teams, but instead choose the most optimal material for every part of the chassis. The top part is an aluminium ladder frame design on which most of the systems of the pod are mounted. Hence, it had to be easy to mount things, easy to analyze, but also withstand the loads exerted on top of it. Aluminium turned out to be the most suitable choice. On the other hand, we have our carbon fiber space frame, which houses the batteries. Because the loads on this part of the chassis are different, carbon fiber turned out to be the more optimal choice. We believe that with this combination of materials and shapes, we've reached the exact combination of strength, weight, and scalability that we deem perfect. This last point is especially embedded in the new three-dimensional shape our pod has attained. It looks more like a full-scale Hyperloop design than ever before, We are pulling out all stops on manufacturing, combining aluminium and carbon fiber, while also utilizing high-tech, state-of-the-art methods like 3D printing titanium connection pieces. Now, as you know, our pod can already brake very efficiently on the propulsion system. But to make operations even safer, we've also designed emergency mechanical brakes. These brakes are designed to be completely fail-safe. By using pneumatics to retract the brakes rather than extend them, we have created brakes that will automatically engage if there's an issue anywhere in its pneumatics air supply. Additionally, these brakes allow us to perform top-speed runs utilizing the entire length of our test track. Now that all the magnetic and mechanical systems are in place, we need a way to control it. This is where our sensing and control department plays a pivotal role. They are responsible for all inputs, outputs, maintaining communication, and providing power to the pod. Essentially, you could think of them as the heart and brain of our system. Specifically, the propulsion system, of which you see a side view here, needs a lot of controlling. To do this, we've developed a localization system entirely in-house. This system uses magnetic measuring sensors to detect where the pod is at all times. It needs to be extremely accurate and fast. If the location of the pod is off by just 5 centimeters when it's moving at 75 kilometers an hour, the entire system fails to work. Similarly, if the delay is just 5 milliseconds, the system grounds to a halt. Without localization, propulsion essentially would not work. Aside from the localization system, Sense and Control is also responsible for all inputs, outputs, and monitoring the pod's behavior. The system senses using all 150 plus sensors to maintain oversight. If the anomalies are too big or the pod loses communication, we immediately brake to maintain safe operations. Now, a system like this would not serve like a complete Hyperloop prototype if it did not have an aeroshell. Because even in the near vacuum environments, there is still a buildup of air in front of the pod. The aeroshell reduces drag, for which it has been optimized by our mechanical department. Not only this, but it also allows for the scalable fact that the pod can move in both directions. We've now shown off the entire Delft Hyperloop 6 system. Everything has been designed such that it is vacuum compatible and can easily be scaled up. The Helios 1 is the best Hyperloop system Delft Hyperloop has built so far, and I'm extremely proud of what we've achieved. Can I please get a warm round of applause for the team that made Helios 1 happen? And with that, I would like to welcome back Patrick to the stage to say a few final words.
Wow, incredible what this team has accomplished in just 6 months. Before we round off for this evening, I'd like to take this moment to thank an extremely important group of people. And those are our partners. Without our partners, this project would not be possible. Every day, we are constantly surprised to see how passionate and enthusiastic you are for this project, and how you are constantly looking for ways to support us and help us. Without you, this isn't possible. Together, over the last 6 months, we've embarked on a journey. We've designed a pod, and we're now producing it. And together with you, our partners, and this incredible team, we are really looking forward to working hard over the next 5 months to win the European Hyperloop Week of 2022. So, ladies and gentlemen, now is the time that we take the lead. Thank you.